Imagine standing on another world, watching a sunset painted in colors no human has ever seen.
On Mars, the fading light turns blue as fine dust bends the sun's final rays. That thin Martian air creates a quiet, winter-like shimmer as the day disappears. Far away on Titan, the sun sinks into a thick golden fog, heavy with mystery. Light lingers there, trapped in deep layers of atmosphere glowing warm and gold. Each world shapes sunlight differently, giving every sunset its own signature. Every planet tells its story through its sunset, revealing what lies in its air.
And next time you watch a sunset on Earth, remember other skies shine in colors still unknown.
Imagine standing on a distant world where the day ends with more than one sun sinking toward the horizon.
In multi-star systems, sunsets unfold like a layered performance of colors, blending and fading one after another.
As the first sun slips away, its sharp white light fades, revealing softer tones beneath it. The second sun follows, warming the horizon with a gentle golden glow that reshapes every shadow.
And then the third sun lingers, its deep orange light washing the sky in slow, fiery waves.
Together, these suns create shifting colors no single-star world could ever produce.
Even your shadow would change, splitting into several shapes as each sun dims in turn. When the final sun disappears, darkness arrives slowly, as if the universe is gently closing the day.
Imagine standing on a world where the surface itself transforms the colors of sunset in ways no Earth sky ever could. On a methane ocean planet, the fading light turns cool and ghost-like, reflected by a glass-smooth liquid surface. As the sun lowers, methane absorbs warm colors, leaving the horizon tinted with eerie shades of blue and jade. But on a lava world, sunset becomes a double fire. Light from the star and light rising from molten ground.
Each wave of molten rock throws back the sun's fading glow, creating a shimmering, restless second horizon. On frozen planets, ice bends and scatters sunlight, stretching colors across the ground like a giant crystal lens.
As the star sinks, ice wreck.
These worlds remind us that sunsets don't belong only to the sky. They belong to whatever surface catches the final light. Every sunset begins with a simple idea: light meeting whatever fills a planet's sky. As light travels, tiny particles scatter it, shaping colors we see, and colors we've never seen on Earth.
On some worlds, fine gases bend light into deep purples or cool jade tones, unlike anything back home.
Even microscopic ice crystals can transform sunlight, splitting it into colors that dance across the horizon.
Thick dust can darken the sky, deepening reds until sunset feels almost molten and heavy. Each world's atmosphere acts like an artist, sculpting its own version of twilight with every passing ray.
And in those final moments of daylight, you're witnessing the sky revealing the true nature of the world below. To understand alien sunsets, we first study the ones we can measure right here in our solar system.
Mars shows us how thin, dusty air turns sunset blue, data confirmed by rovers on its surface. Titan teaches us how thick, hazy atmospheres filter light into heavy golden tones.
Uranus reveals how methane shapes color, shifting sunset toward cool turquoise and soft violet.
These worlds act as natural laboratories, letting us test how light truly behaves in alien skies.
When our models match the sunsets we've measured, we know they can be trusted for distant worlds. Each confirmed sunset strengthens our ability to imagine those on planets we may never reach.
So every alien sunset begins with home, our own.
Red dwarfs shine weakly, turning the sky into a deep ember glow that lingers far longer than on Earth.
Because their light is so gentle, it takes hours for a red dwarf to slip beneath the horizon.
Time feels stretched, as if the entire world is suspended inside a single extended twilight.
With each minute, the star dims gradually, softening the world instead of plunging it into darkness. Some planets orbit so close that the star moves barely at all, trapping the sky in near-permanent dusk.
Life here, if it exists, would grow under a world painted permanently in shades of red.
And as the final light fades, you're watching a sunset shaped by the smallest, most common stars in our galaxy.
Imagine standing on a massive world where gravity bends light and changes how a sunset truly ends. On super-Earths, sunlight doesn't vanish. It bends, lingering long after the star has slipped below the edge. You watch the star sink, yet its outline remains suspended, as if refusing to leave the sky. Twilight lasts far longer, stretching into a soft glow instead of dropping sharply into night.
With each moment, you see light from places already hidden. Guided.
Even the horizon looks different, wider, lower, shaped by a world far stronger than Earth. And as the final glow fades, you witness a sunset shaped not by air or clouds, but by gravity itself.
Imagine standing on a world where winds race at thousands of miles an hour.
These superwinds twist dust and gas into colossal spiraling ribbons across the sky. As sunlight pushes through this chaos, it bends and scatters in strange, shifting ways. The sunset doesn't fade smoothly. It ripples, trembles, and reshapes itself second by second. Sometimes the star stretches into a blurred band of light, torn by fast-changing layers of air. Other times, the horizon flickers with multiple ghost-like reflections of the sinking sun. These strange sunsets reveal how violent winds can sculpt light just as powerfully as any terrain. And when darkness finally arrives, it feels earned, after a sunset shaped by storm.
Every simulated sunset begins where science and imagination meet.
We start with real data, atmospheres, stars, and physics that shape how light behaves.
But numbers alone can't show what a distant world truly feels like at dusk.
So we let science guide the boundaries, and creativity fill in what no instrument can see. Each scene is a handshake between evidence and artistry, grounded yet full of possibility.
These sunsets aren't made just to look beautiful. They're built to help you understand distant worlds.
When you see a purple horizon or a stretched sun, you're glimpsing science translated into emotion.